Here's the MM1 Finite Source demonstration and Department of Commerce case. And I have just entered data. Arrival rate is 0.05 that we have calculated over here, 0.05, and the service rate mu, 0.5, and the number of channels, we have only one channel, and population size n equals 5, and downtime cost is given as $120, and technician cost $25. And we have to start with the P0, and P0 has quite complicated formula as this. So P0 equals 1 over um, uh, sigma n from n equals 0 to n, and n factorial over n minus n factorial, and lambda over mu to the power of n, and that has to be calculated. So the approach I have taken again is to break them down, right? So first I want to calculate this n factorial over n minus n, and then I want to sum them up together and then add them up, and then we are going to divide it by 1. I mean 1 over that summed values, and then we are going to be able to calculate P0. That's the strategy that I want to use again. So let's do that. So here is the formula for when n is 0, 1, 2, 3, 4, 5. We have only n is 5, it's determined, and what we are using this number for is n. So this lowercase n is 0 to 5, and it's changing, and we are going to use that to calculate the summation values. So let's go for here. So here's factorial I7. I7 is right here. Population size n is going there, and divided by factorial over n, 5, minus lowercase n is given here n as k19, and I calculate that, and multiply by power function I'm using because to the power of n is right here. So power and lambda over mu, 0.05 divided by 5, and then comma, and n is the power, so I'm going to put 0 or k19 here, right? So I just express this one into Excel and copy that formula down like this. Then I have 0.1 and 0.5, 0.2, and so forth to 0.0012 as this value. And then I have summation of that. So notice that n0 to n, I'm not subtracting n minus 1 like that. So I'm starting from the first row, so which is 1, right? The same. And then the second one is 1 plus 0.05, that's 1.5. And then 1.5 plus 0.2, that's 1.7, and so forth. So now, lastly, 1.772 plus 0.0012 gives you 1.7732. So that's what you find for that. And now we are ready to calculate P0. So P0 equals simply this 1 divided by 1.7732 will give you the value. So 0.563952177 is the value that you are looking for. So let me highlight this for you. So this is P0 value, and I just enter this P0 value right here, right? And Pn I have calculated, so that's right here. So so I just put the formula in there and copied it down, and Pn for when P is 5, you have 0.0006767. So that's what you can calculate. And LQ is right here. LQ is n minus lambda plus mu over lambda times 1 minus P0. So I also put the formula in there and calculate it. I have LQ is 0.203 and L is 0.63 from this formula, and WQ over here, LQ over n minus L times lambda. I calculate that, and that's 0.933, and W is 2. W is WQ plus 1 over U, almost mu. So R24 over here plus 1 over mu will give you that value. So I was able to fill this out. So the percent idle time is about 28% of chance you have by using these new compactors for this business. And LQ, average time a customer spends in the time, is about 0.20 per hour. Q, average number of customers in the system, and we find that that was 0.63, and W, average wait time, is 0.93, and WQ is 2.93. So that's what we find in this case. And lastly, we can calculate the total hourly printer downtime cost is L times 120, because the number of the times that you are experience the printer breakdown. So that's L times 120, and that gives you $74. And cost per technical hour is $25 per hour, and that's per hour. You have that. That's 1 times 25 will give you that value, and total cost is going to be, just add them up, and $101.74 is the cost that you have. So that's how you can solve this question. And again, it's quite complicated. I think when you have, instead of 5, say you have 7, then you have to increase it to 7, and the number has to change to 7, right? Population size has to change to 7, and then you calculate that, and you will have the answer. Okay? Thank you.